Hi, everyone. This is a recording of the talk I gave for the Collaborative for Human Factors in April of 2023. So I'm Erican. I'm a medical scientist training program fellow, which is just a fancy name for an MD PhD student. I'll be graduating in 2024, so next year. I defended my dissertation in engineering last summer in August. Have a big focus on machine learning development and implementation, specifically building predictive models for use inside the hospital. Previously, I worked on healthcare data and data science, and I was an engineer at Epic. I do have some conflicts of interest. I have a patent pending for an AI prediction tool used for occupational injuries. I have a small amount of stocks in my retirement account for various technology and healthcare companies, and I do provide some AI advising for several startups. So this talk has 3 parts, but we only had a chance to go through 2 of them in the collaborative's meeting time. So the first one is an introduction to artificial intelligence, and then the second one is a little bit of a overview on ChatGPT. And so we'll go over these 2 talks in this recording. So I think it's often helpful to talk about some definitions, and I think Wikipedia often has quite good definitions. So these are adapted from Wikipedia. So artificial intelligence, or AI, is intelligence demonstrated by systems constructed by humans or machines or computers. Intelligence is a hard concept to pin down, but we can broadly categorize it as the ability to perceive, synthesize, and infer information. Machine learning is a subfield of artificial intelligence that is interested in developing methods that can learn. Learning refers to the ability to improve performance on some task using data. There's a lot of potential tasks, but an example could be detecting if a pathology slide contains evidence of a cancerous cells or not. An AI system might use a lot of historical slides along with pathologist interpretation to learn how to detect evidence of cancer in a new slide. As mentioned before, machine learning is a subfield of artificial intelligence. Artificial intelligence, or AI, contains several other domains, such as natural language processing, NLP, which is the ability to process human-generated text or speech. It also contains knowledge representation and reasoning, KRR, the ability to encode human knowledge in a way that we can automatically process. And another big subdomain is perception, which is the ability to process inputs from sensors like cameras. Oftentimes, AI and ML are used synonymously, but it's important to note that there are a lot of different AI goals and techniques. Machine learning contains a set of techniques called deep learning, and in the last decade, these have become very popular because they've proven to be very effective. And as a note, these techniques aren't totally self-contained. They overlap and interface with a lot of other topics. For example, machine learning draws heavily from optimization, operations research, and statistics. The successful implementation of AI tools depends on an understanding of human-computer interaction, or human factors engineering, and concepts from economics like game theory have been fundamental to the development of AI systems. So this is not an exhaustive list. It's just meant to show you the richness of the subject area. And I think what's particularly interesting to folks in the collaborative is that I believe there's a very rich area of intersection between human factors engineering and artificial intelligence, and much of the work that we're going to be spending the next probably decade or so working on is figuring out how to get these tools to work well with human users, and that is fundamentally a human factors engineering problem. So you've all likely interacted with AI systems. Even in the span of today, you've probably used a handful of applications that heavily depend on AI. Here's a couple examples from my home screen. So on the left is a screenshot of my spam folder. Spam detection is a classic AI problem. I think it might actually be a required project for all undergraduate AI classes. The middle one shows a GIF of me asking Siri to play some music. The Siri system, like other chatbots, is built on a series of AI tools ranging from voice recognition to natural language processing. Finally, on the right, we have route planning generated by Apple Maps. Calculating the shortest routing between 2 points is a classic operations research problem, and these mapping tools often incorporate traffic congestion prediction into the system, which is another form of artificial intelligence, and that it helps to enable users to avoid traffic. AI is also deeply embedded in the way many companies operate. Industries with thin margins, like airlines and e-commerce, use AI to optimize their operations. They have tools that predict demand and how to price products. Additionally, they will use predictive models to determine when critical infrastructure will need to be serviced, like when plane engines should be overhauled. Tech companies also use AI tools because they have tons of data. They might use this data to predict what content will keep users engaged with their platform and what ads might get clicks by certain users. So medicine is a data and knowledge-rich field. If you think about medical school, it takes 4 years to gain the fundamentals of medical knowledge. It then takes another 3 to 9 years to master independent clinical decision making. The decisions we make in medicine are multifactorial. They depend on subjective and objective data. Additionally, we're often guiding others to make decisions in line with their specific values. On top of that, we have an expectation that we should learn over time. We shouldn't make the same mistakes over and over again. And we're striving to improve our diagnostics and therapeutics as well. So AI offers us an opportunity. It gives us techniques to rapidly summarize information, predict outcomes, and to learn over time. Finally, general society has big expectations of AI in the field of medicine. Whenever you read popular press articles, oftentimes medicine is the quote unquote killer application when AI is mentioned. Despite these potential benefits and expectations, AI is not part of medical education. The use of AI in medicine is not straightforward. It's not as simple as making a mapping application and putting it out on the Apple App Store. Implementation requires a wide variety of expertise, ranging from engineering, human factors, to privacy and ethics. AI tools depend on complicated data and workflows that physicians understand. Healthcare data cannot be analyzed outside of the context that generated them. For example, what's the value of a single lab value without all the accompanying values or historical trends? Without the physician's perspective, AI tools may not function properly. Additionally, the adoption of medical AI technologies is increasing. Most academic medical systems probably have a handful of AI models running currently. And as this begins to accelerate, we leave learners at risk of being unprepared. So I'd argue we must prepare new physicians for using, assessing, and developing AI tools. So sometimes the clinical setting seems removed from AI. I would argue that this is unlikely to remain the case for very long. So this plot is the total number of AI medical devices cleared by the FDA. As you can see, there's been a increasing trend in the number of devices cleared. In 2015, there were 29 devices that were cleared by the FDA. And last year, so in 2021, the FDA cleared their 500th AI software medical device. I'd like to note that this is actually a leading indicator. Not all AI software needs to be cleared by the FDA. In fact, most AI software in use right now, I'd argue, is actually not being cleared by the FDA. So here's an example of a FDA cleared device that we use for chest x-rays here at Michigan. So this software was cleared in 2012, and it took a couple of years for us to start using it. I think I noticed it, relatively recently within the last couple of years. So if you order a chest x-ray, you'll see an additional radiograph with the ribs automatically cleared from the field, which is pretty cool. I haven't done a lot of additional research to see, what are the problems associated with it, but it's cool to see it sort of being implemented as a additional piece of the standard operating procedure of care, if you will. So internally at Michigan, we've been pretty active at developing and implementing AI tools. So these are some of the models developed, implemented, or assessed by teams that I've been part of. And while model development is pretty fun, I'd argue the biggest contribution that physicians can have is in the implementation and validation of AI systems. I've implemented several models built here at Michigan, and I found implementation to be challenging from both a technical and a workflow standpoint. Without a strong clinical perspective, we run the risk of having AI models be a burden as opposed to being an assistant. So the rightmost example um, is a study where we evaluated a model and deployed by Epic. It's implemented at hundreds of hospitals in the US and used by tens of thousands of providers. Lots of physicians had reservations about this tool, but didn't have the data or expertise to surface its very real issues. Despite its wide usage, we found some issues with the sepsis model that were hidden due to their proprietary nature. So, given some of our findings, Epic has actually revised the sepsis model. So all of this activity underscores the fact that we have to start training physicians on the fundamentals of AI. It's not really acceptable for physicians to take the role of a passive user of this technology because there's very real benefits and very real risks to these tools. And I'd argue that we need to understand these risks and benefits. As such, we need to be actively involved in the creation, evaluation, and improvement of these systems. Anything other than full engagement with these activities is dereliction of our duty towards our patients. In order to lead in this space, we need to understand these tools, which is expanded upon in our recent Cell Reports medicine paper. And I'd argue that we need to partner with experts in these tools, like all of our friends in engineering. So the second part of this talk is a very brief sort of primer on ChatGPT. And this is actually what had gotten the collaborative interested in talking about artificial intelligence. So I'd be remiss if we didn't go into this sort of briefly. So ChatGPT is a chatbot that runs on the GPT machine learning model architecture. So it was developed by OpenAI. OpenAI is a research agency a research organization slash startup that develops machine learning and artificial intelligence tools. They were sort of nominally developed to do this stuff in a sort of an open manner for the general good of society, but they are sort of now a subsidiary of Microsoft. The chatbot they developed is a mix of supervised and reinforcement learning, and we won't go into the details here, it's sort of beyond the scope of this discussion. But one of the things to think about in terms of how it works is it's based on this GPT-3 model architecture, and that stands for the Generative Pre-trained Transformer 3, because it's the third version. And all it is a type of large language model. And you can think of that as a fancy predictive text system. So, everyone is probably very familiar with this task, but you can think about like, okay, you've written the sentence, the quick brown fox jumps over and you're about to type the next thing. Well, you can have your keyboard recommend, what's the next thing to put in for the next word. And the way these work is they can think about all the different words in the English language and they can assign a probability to say, well, the probability that the next word is lazy is 95%. And then they can sort of calculate the probabilities for every other word in the English language. And the way that they generate these probabilities is by taking all the data that's accessible on the internet, downloading that data, and then building a model that can learn the relationships between strings of words. And so that's sort of the way GPT works. It's basically a way to figure out what the probability distribution between all the different word sequences are. And that's fundamentally what generates the text that you see coming back from the chatbot. There's sort of a tricky problem with how do you conduct chat effectively? Because if you think about chatting, it's sort of a branching tree. So if I'm asking questions of a chatbot that's answering, I might ask my first question, and there may be, a couple different ways to answer that question. So you could think about, there's three different answers, and the chatbot will choose maybe one direction to go with the answer. And given that answer, then I may ask another question, and then there may be different directions to go. So you can think about this as a sort of constantly branching tree. And so, you would like to ideally be answering questions with good answers and keeping people engaged, because um, ideally you're sort of answering their questions, and also you get to keep them engaged for whatever purposes you have. So one of the things that they do is they do this type of reinforcement learning with human feedback, where essentially before the system went live, they had people chat with the chatbot, and then the users were able to give feedback in terms of thumbs up, thumbs down, in terms of the quality of the answers. And this allowed them to learn, okay, generally these are better answers to choose in this scenario. And even if you log in now to ChatGPT, you'll still see this feedback. So you can give it, thumbs up or thumbs down. And this feedback is ultimately what helps to figure out which direction down the branching tree should the chatbot go. So there are many issues with large language models, which are, the GPT part that generates the text of ChatGPT. And one of the biggest is, they are based on whatever data they were trained on. So if you're using all the information on the internet, you may have experience with this, but all the information on the internet may not be relevant to what you're trying to get answers for. It may not be accurate, or it may not even be pleasant. So you have to worry about all three of those problems when you're building something using that data. The generative process is inherently stochastic. So the way that responses are chosen or sentences are constructed actually depends on sampling the distributions that it sort of observed. So it's not always going to pick the most likely next word in the sequence when generating a response, because if it always picked the maximum probability, then there would be no variation in responses, and there would be it wouldn't feel very naturalistic, and you wouldn't be able to explore this branching tree also. So there's inherently stochasticity in the way it responds. So you don't necessarily know, even given the same setup, that you'll end up with the same outputs, even if you gave it the same inputs. And this leads to, the third major issue, which is they're very hard to evaluate and verify. So, you might ask, well, how often is ChatGPT right? Well, I don't know, because first of all, like, what is right? Like, what do you mean by right? Like, how often are they giving you the correct answer? Because then we would need to, assess, well, what is the correct for a given scenario? And because it's natural text and there's a lot of subjectivity to it, the interpretation around it, it becomes an increasingly difficult task to actually evaluate, how often is it going to be right? So the third part of this talk was going to be research at the intersection of AI and human factors. We didn't have a lot of additional time for this, so that's held for a different day. But I wanted to jump sort of directly to the recap at this point. So AI provides medicine with a set of powerful tools. I'd argue that we need to train physicians to be active leaders of the development and evaluation of these tools. ChatGPT is cool, but problematic. The things that we didn't really get to talk on much, but I think are germane to the discussion with the collaborative as a whole, are that healthcare AI, the life cycle of healthcare AI is dependent on physician-engineer collaboration and sort of very deep longitudinal collaboration. And the interfaces between physician users and AI tools will need significant human factors engineering. And so with that, it sort of concludes the presentation. Feel free to reach out to me with any questions or comments that you may have. And so I have my Twitter handle there, and you can also go to my website and shoot me an email from there, or just shoot me an email directly too. Thank you very much.